So welcome back students. Let's start the session.
Afternoon.
Can you hear me?
Yes, sir, you are audible.
So in the last class we have discussed quartile deviation and definition on that, and let's do the some problem based on that. So now can we refer the previous examples so that like these examples we can refer or thing. Yeah. So for example this one, or you may consider any raw data example like you can ask any examples. Okay. So if you just consider this example only, here you have already found quartiles. Yeah. So if you just refer this example, okay. In that example, you need to find out Q1. So referring example number 19, referring example number 19, you may get Q1 will be 30, Q3 will be 37. Okay. So you can refer these examples once again. I'm just muting to everyone, so there should not be any disturbance. So example number 2, referring example number 19 of unit 2. Okay, you may get Q1 is 30 and Q3 is 37. Okay, so based on this Q1 and Q3, based on Q1 and Q3, you may calculate the interquartile range. So IQR, which we called interquartile range, which is Q3 minus Q1, which is 37 minus 30, so answer becomes 7. And hence one can find QD, which is quartile deviation, which is 7 by 2, which is 3.5. Okay. Similarly, one can find coefficient of quartile deviation. So if you have any questions, you can put on the chat box because I have mute to all. Okay. So you can put on the chat box if you have any query. Coefficient of QD is going to be Q3 minus Q1 upon Q3 means I can write 37 plus 30. Okay. So you can just calculate this value and let me know the answer. What should be the answer? So this is going to be 7 upon 67. Put your answer on chat in chat box. So answers is 0.104 according to given by students. Yeah, 447. Correct. Okay. So this is a few example. I can consider another example, example number 3. So we can take example number 3 again from the unit 2 only. So 19th we have taken, you can consider see there are several examples. Okay, so you can refer anyone for solving that. You can refer example number 22. Okay, so example number 22. Are you able to see the screen? Are you able to see the screen? Go to chat box and write down. So this is example number 22, which we have already solved. Okay, and in that case, we need to compute all quartiles D3, D5, D8, and so on. Okay, so here we have a data regarding some wedges or maybe some interval. You need to compute Q1, so you know how to compute Q1, and you need to compute Q3. Okay, so I'm just taking these data directly in the unit 3. Okay, because otherwise if you start doing calculation it will take time to doing that all. So question number, refer example number 22 of unit 2. Okay, or I will be say measure of central tendency, because I think in GC I have put in that way 1 2 3 4 5, right? So central tendency 4 you can refer, means whichever way you can say. So this is unit 2, I can call notes 4, notes number 4. Similarly, notes number 4. You can refer that and you get Q1 ka value and similarly Q3 ka value. So Q1 ka value is 183.26 186.2692, and this is a Q1. Q3 ka value is 227.1875. 227.1875. Okay. So based on that data, like this data, you can get these values, and once you get these values, you can compute quartile deviation. What is the quartile deviation formula? It is Q3 minus Q1 upon 2. You can just substitute and let me know the answer. So you can find coefficient of quartile deviation, which is Q3 minus Q1 upon Q3 plus Q1. And just substitute and let me know the answers of this. So what is a QD? Quartile deviation? Tell me final answer, because we have these data.
73.8.
Answer is something else. Okay. So what is QD? So QD is coming 20 point something, 20.45. 20.4589, 24 point. Why they are getting different answers? Everybody getting fractions. After fraction, it is changing. One more different answer. See, if I have given the same data, like 26.92 and 1.87, same data, but everybody is getting a different answer. So, what is the perfect answer? So, what should I consider? Yeah, one more answer. 95 something. So, I think we can 20.4.91. What about the coefficient quartile deviations? So substitute these values like 20.4591 divided by addition of these two values. So you may get the answer for the same. So what is the answer? Coefficient of quartile deviation is that 0.0986 something. Yeah. So that is 0.0. So this would be the answer for that. Okay, go ahead. Now you can understand how to compute these values and how to do the calculation based. That is all fine. You can do it. It's very simple. It's very simple. Okay, but you try to understand in what scenario you're going to use this method. That's a more, I can say, appropriate. Okay. So again, we talk about the note. So what note says, like, first of all, I have already mentioned that the QD, the quartile deviation, is a independent of extreme values. I have already mentioned. Right? Means it doesn't depends on the very lower value or very higher value. Okay. Therefore, I can say it is better representative and more reliable than range. Okay. Second one, as you already knowing, the QD means it's a quartile deviation. It's you the distribution of a middle half of the observation around the median. Around the median. Okay. And the very important thing is that whenever median is referred median is referred as a measure of central tendency quartile deviation, I can call QD, is referred as a measure of dispersion. Are you getting the point? So whenever you are considering that, whenever you are saying that median is appropriate measure of central tendency, I may use quartile deviation will be suitable for measure of dispersion. I may not use range in that scenario. Okay. But when you are saying the mean is appropriate measure of central tendency, then for dispersion you need to find some other I can say technique, not quartile deviation. Quartile deviation fails in that scenario. Okay. So that just remember these concepts. These are the very important concepts. Okay. So that means I can conclude with that. Whenever in my data uh, it's something very extreme values are there, uh, I am going to use median concepts, and based on the median, in the case of dispersion, I'm going to use quartile deviation. Just remember, these are the few logical concepts which is very important. Okay. And then I can say you may consider several examples like how they, for example, I will say you have given the marks data of two classes. You have given the marks data for two classes, and you are willing to check whether uh, which division or which classes are better as compared to the marks. Okay, so you may find whichever the coefficient of variations are less, that class is going to be better. Okay. So I think we have so many examples in the practical. So when we conduct the practical, you may be get more examples. Okay. And then we'll proceed with that. No problem. Then let's move to the next part of that. What is next part? So the example number 3 is done. Let's go to the example, not example, or next method. So MD. Next is MD, which is called as a mean deviation. Next is, sorry, next is mean deviation. Okay. which is I can call M. So again, there is a new method, but I will not talk about the, I can say, mathematical expression will be more, but importantly, when you are going to use this method, that is the important perspective of taking this method. So again, if you just consider this method, quartile deviation, so you may come across like uh, somewhere we are leaving some part of observation. Means if I'm just taking consideration of like only 25% of the data or 75% of data like Q1, Q3, still I'm losing some information regarding that. Okay, still I'm losing some information regarding that. So in that case, in that scenario, I'm not using the entire data. Are you getting my point? So somewhere I'm failed to get more, I can say, more idea, more knowledge about my uh, method. Okay. So to overcome this problem, one may use the mean deviation, which is called mean MD. MD called mean deviation, and it is also known as MAD. What is it, MAD? MAD means it's a mean absolute deviation. This is called as mean absolute deviation. One can say also MD in deviation, or one can call MAD, which is mean absolute deviation. So let us see what exactly it is. Okay. So we know that range and QD, quartile deviation, are not based on based on all the observation that we already know, right? All the observations. So also they do not indicate they do not indicate the scatter of the observation from average value from average value. So MD overcome overcomes both these drawbacks both these drawbacks of the earlier measures of dispersion. Okay, so now let's check definition. So definition, again, we talk about the raw data and we talk about the frequency. Okay, we talk about the raw data, we talk about the frequency. First, we will take for general case. What is general case? MD is, I will say, MD or mean absolute deviation is defined as the arithmetic mean of absolute okay. So what is the definition of a mat? It's a AM of absolute deviation of observation from any suitable constant. From any suitable constant. So that means I'm going to take the absolute difference. I'm going to take the absolute deviation. And this means what? I'm going to take the absolute. Absolute means you are knowing it's a mod. It's a absolute deviation, absolute difference of their AM. AM means divide by n with summation of observation with any suitable constant. With any suitable constant. So it's arithmetic mean of absolute deviation means absolute difference of observation from any constant. So this is the definition. So according to this, one can make this. I can say I can call the expression. Okay. So if we assume, if we assume what we assume, variable x can take values x1, x2, so on xn, and a be any constant value, any I can get arbitrary constant, or I can say constant value, any constant, then mat or MD from A is defined as, how defined? MD from A is equal to 1 upon n, or I will say like this. I will say like this. It is summation mod of x minus a upon n. Any questions so far? Anyone? Any questions so far? Anyone? So if we assume for a frequency distribution, where class intervals and frequencies are given. So in that scenario, how to define? In that scenario, how to define? Therefore, MD from A is going to be, you have to just add up here summation of f x minus a upon summation of f, I can call it n, which is here n is nothing but summation. Hence, I can say, the corresponding relative measures of dispersion is, that is, coefficient of MD from A is defined as MD from A divided by So let me know if you have any question related to the definition. Any question? Or let's go to the example. Okay, good. Let's go ahead. So it's very simple. It's very simple. It's very simple. Why it is very simple? Because these type of problems we have already deal. Like where we talk about summation. But only difference is that here we have considered the, I can say only the mod concepts. Okay. So mod will be more introduced here. So let's see the problem based on that. So let's take example number, I think example number 4 now. Take down, calculate MD from median and corresponding coefficient of MD from the following data. Okay, so let's take the data. It is 100, 150, 200, 250, 360, 490, 500, 600, 676. Take down solution. So what you have to do here, you need to calculate MD from median. MD from median. But can I give in the formula for MD from the median? No, because this A is my anything. This A can be my anything. It can be mean, it can be median, it can be any value, it can be mode. Getting my point? So that's why in general I have given the formula for MD from A. So A is any arbitrary constant which can take anything. Okay. So that I will be showing you the in the node part. Okay. So see, so whatever things we are facing the problem, why we are why this is all facing the problem. Okay. So that is all basically a note, or you can say drawback, okay, or you can call limitation, etc. Okay. So that we will put in the form of note. So how do we calculate this MD from median? So to calculate MD from median, so to calculate MD from median, we need to calculate median. Okay, we need to calculate median. So as I told you, to getting median, we have to arrange the data in order, right? Arrange the data in ascending order. So put the data in ascending order. Put the data in ascending order. So putting data in ascending order. What you will be getting? Put the data in ascending order. So it is 100. But I think if you just look at this data, this is already in order. Okay. But these steps will be the common for all observations, all the problems. Okay. So make sure that here I have already given the data in order, but you should always go with the proper systematic way. So just count 2, 4, 6, 8, 9. So your n is 9, right? And to get the median, what is the formula for median? When n is even, we have a formula n, we take middle value. When n is odd, we take, what is the formula? N plus 1 by 2th observation. Okay. So this is 10 by 2, that means 5th observation. So 5th means it is around, is it 360? So if you should, yeah. So if you look at shortcut method, what I told you, you partition the data into 2 parts. 2 parts divided kaise rahega? 4 from here and 4 from here, like this. This way. So this value become your median value. Okay. So once you got the median, what is the formula for MD from that value? So we have X data, okay, which is 100, 150, 200, 250, 360, 490, 500, 600, 676. You calculate here now mod of X minus median. So if you just calculate that value, you need to calculate, okay? And then based on that, you will be get the next value. So if you just subtract that value, what you will be get here? Let's see. So 100 minus 360, even it is positive or negative, doesn't matter. It is always going to be positive. Negative bhi rahega to bhi answer will get positive because we are considering the mod value. So if you 100 minus 360, answer is 260, and so on. So I'm just writing the answers. You just check whether if any correction, then let me know. Zero. This is 3 and 130. This is 40, 140. This is 240. And finally, this is 316. Therefore, MD from median is equal to summation mod of X minus M upon N. It is going to be, just add up this all and divide by 9 because N is 9. So is it 1566? Please check it and let me know that whether it is right or wrong. So you should get MD from, I can say, median is this. Am I right or wrong?
Right, sir.
So you can, once you get this, you can find the coefficient of MD from, oh, you can call it coefficient of MD from median, which is nothing but MD from median upon median. Okay, so you can just calculate those values and let me the answer for the same. So this is going to be what? This is 174 upon median is got 360. You can just calculate.
0.486.
So answer becomes 0.4833. Any question to anyone? Okay, so you take one example for practice. Example number 5th. Take down example number 5th. Example number 5th is for practice. Take down. Find MAT from first one mean, second one median, third one mode, fourth one 21. I can say for the following data. For the following data and verify that math is minimum when taken from median. Taken from median. Okay, we can take observations. 17, 19, 18, 22, sorry, 22, 19, 18, 19, 21, 19, 20, 24, 20, 23, 25, 21. Just count how much it is. Is it 15? 10.
Yes,
Yes,
sir.
sir.
15
Yeah.
options.
So this is a practice. Okay, this is a practice. You should try this example and tell me next time what could be your answer. Okay. So if you have any question to related to this practice answer question, you can ask. Like if you have any doubt. Otherwise, we can go to the example number 6. So I'll leave some space for this so that we can verify the answers next class. Yes? Any question? So you need to obtain the mean for this. You know how to obtain the mean for this, median, mode, etc. etc. Right? Then if you have to find the mad from mean. So again, you have to make a same class x minus mean. X minus mean. इसका data निकालो, and then you can take the same formula. Summation x minus mean divided by n divided by 15. आपको कुछ आंसर मिलेगा. Similarly, you do it for median. Similarly, you do it for mode. Similarly, you do it for 21. मतलब 21 एक ऑब्जर्वेशन दिया आपको, मतलब यदि कांस्टेंट वैल्यू दिया है, सबका आंसर्स निकालो और वेरीफाई करो. क्या बोला है? वेरीफाई. वेरीफाई मीन्स हैव टू प्रूव. वेरीफाई मीन्स वी हैव टू प्रूव दैट MAD is minimum. That means mean deviation is minimum. MD is minimum. Mean absolute deviation is minimum when taken from mean, taken from median, taken from median. So whenever you consider the data, and you're considering the median and rest all central tendency like median and mode etc or any number, we can verify that the MD from the median is always minimum. This is one result. This is one result that I will show you in the next class, the mode part. Okay. Or you may try for one, I can say, uh, simple example, not very big example. Like this. Find MD and coefficient of MD from the following data. Following. We have the data for each. You can call this X. You can call number of students, which is called F. Okay. So you have age become 17, 18, 19, 20, 21, 22, 23, 7, 11, 17, 30, 30, 1, 5, 15, 12, 8. Okay, so you can consider this is, you can call ungroup data and you can try to solve that. And so again, the procedure is same. You can calculate the MD from, I can call, can calculate from mean. Okay, so I can say use both the method here. Okay, use both the method. Like you can find for mean as well as median, and tell me which is better. Better means you should be obtaining coefficient of mean deviation, and whichever is minimum, based on that we're going to conclude your result. Okay, any question? Sorry. बोलो. Your voice is not coming, Vishwajit.
तो मीन से डेसिमल में आ रहा है.
Mean? आवाज नहीं आ रहा है बेटा आपका.
एज्यूम करना पड़ेगा.
Put in the chat box. You can calculate mean, you can calculate median, and then based on that, you can calculate MD from mean, MD from median, and then based on that, you can obtain the values. If the mean is coming in decimal, you have to take up to 2 decimals. There is no choice. Okay, you have to consider for 2 decimals. So approximate, you consider 2 decimals. Like if it is coming, for example, if अगर आपका mean आ रहा है, for example 20.03, for example, so 20.03 you subtract from 17, which is your x, because you have to do x minus median, right? X minus median. So what formula you have to use for here? Here MD from mean, क्या formula use करना पड़ेगा आपको यहाँ पे? So what are the columns required here actually? So when you create the column, okay, let me just write the formula for this. MD from median, what would be the formula? It is summation f x minus x bar upon n. So you need to calculate the x, this is your x value. You need to calculate x bar. X bar आपको मालूम है, just multiplication करना है और you may get the answer for the same. तो आपको कॉलम कौन सा बनाना है? यहाँ पे x का ऑलरेडी है मेरे पास. Create one more column x minus x bar. Then create one more column f time, or I can say I can calculate directly mod also, right? Mod of that value, and then calculate f time x minus mod of x. This is in the case of mean. Okay. For a case of median, just give me a minute. Just give me a minute.
किसका जो है ये? मेरा हो सकता है ऐसे ऐसे करती है ना. मेरा नहीं है. म्यूट. म्यूट द सर.
Can you hear me, students?
Yes.
Can you hear me?
Yes sir.
हाँ.
मतलब भी नहीं है.
तो पहले आप क्या करो, आप मीडियन के लिए निकालो आप, ठीक है? सॉरी, मीन के लिए निकालते पहले हम लोग. जस्ट कैंसल दिस. फर्स्ट वी कैलकुलेट ना. प्रॉब्लम में यहाँ पे दिया नहीं है, बट यू कैन ऑलवेज कंसिडर एक्स बार के लिए एंड मीडियन के लिए. So that I am giving in terms of like here. So first we calculate for mean. Okay, MD from mean. So MD from mean के लिए क्या करोगे आप पहले? You calculate. I will say x मेरे पास है. Calculate करो. fx calculate करो. और उसके बेसिस पे ये calculate करो. तो x का डेटा मेरा क्या क्या दिया है वो लिख लो यहाँ पे. What could be x? It is 17, 18, 19, 20, 21, 22, and so on. Now calculate fx. In this into this and so on. Okay? वो सब calculate करो, मुझे आंसर बोलो.
अब बोल रहे हैं. Fx.
Can you understand me? Are you understanding me?
17, 17, 17, 34.
Asha Yadav, can you hear
Yes,
me?
sir.
Can you hear me? No worry, don't worry, don't worry. You can just calculate. Okay. Yeah. So Ashish sir will be not going to take the lecture because he has completed portion. So I will just continue with that. So we'll do few examples and we can stop. No problem. So you can just calculate these columns. These columns are very simple. You can use the calculator and get the answer for that. Okay. So just tell me the mean of that value so that I will go on doing this calculation. So is it mean is coming, I can say 20.3, 20.03. Please check it and let me know. और इधर थोड़ा एक और ऐड कर सकते हैं आप, if you want, like this you want, because f भी लिख लेंगे तो थोड़ा सा आपको इजी हो जाएगा. f मेरे पास है, fx निकाल सकते हैं and then you can find this, you can find this. So the total of f is going to be, I think, 100. You can calculate x bar. Once you calculate x bar, you can calculate this column. You can calculate this column. Then take the total.
19.83.
Sorry,
19.8.
19 point. Just calculate and let me know answer. Students, please do the calculation and tell me the answer for the same. So I'm waiting for your answers. Okay. So this is 7, 11, 17, 30, 15, 12, 8. Do the multiplication. So you'll get the 119, 198, 323, 600, 315, 264, 184. Total become 203. Just check it. Is it coming 203? 2003?
Yes, sir.
Yeah. So you can calculate like this. So just tell me final answer so that I will not write anything on the screen. So you can just calculate that value. So MD from median, sorry, mean is going to be what? Tell me just total of this so that everyone please cross check that answer whether you are getting this is correct or not. Anyone got this value? The summation of f x minus x bar upon n, which is I know it is 100. Yes, anyone got this summation sign का value? Sorry, this is not 100. This is mean, correct? Yeah, just a minute. Yeah, it is n, correct. So just divide by n. What is the summation of f x minus x bar? Can you tell me anyone? Anyone can tell? So you can put your answers in chat box or you can write it down. I hope everybody is doing calculation, right?
Yes, sir.
Yeah, because I'm waiting for answers from your side.
3.9.
What is the answer? Tell me some
123.9,
first.
sir. Total sum.
Tell me some.
Sum, sir. Sum. Yes, sir. Summation नहीं बता रहा हूँ. 123.9 आ रहा है.
150.
123.9.
123.
123, sir.
No, your voice is breaking. It put on the chat box.
9.
Just put on. Just put on the chat box. Well, because your voice is breaking. So 123.9. Okay, and divide by 100. So you'll be get 1.239. Correct? Now, can you obtain coefficient of, like you can just find coefficient after this, okay? So the coefficient of MD from main, which is 1.239 upon mean, which is 20.03. Put your answer in chat box. Huh? Put your answer in chat box. Answer is 0.06. 0.06. Yeah, so many answers. 0.061855. Fine. Now what you have to do, you have to find out median from median, MD from median. Okay. MD from median. So MD from median. So we calculate median first. So how to calculate median? Remember, in the case of raw data, you remember how to calculate the median in the case of ungroup data. You need to find out CF for this,
Yes, sir.
and then
L
based
plus
on
n
that,
by 2 minus CF divided by S into S.
so if you just calculate n by 2, which is 100, sorry, 100 by 2, which is 50. So 50 will be lying which value? So if you just go and add up these values, तो कितना हो रहा है ये? 17 plus 7, which is 18. 18 plus 17 is 35. 30 plus. So I think your
35
median is
plus
20.
20.
Yeah.
Yes, median plus 20.
Yeah. So implies that median is 20. And once you get median is 20, I think you can do all tasks here, right? तो आप एक काम करो, यहीं पे एक और कॉलम बनाओ, इसका mod of x minus 20 and f of mod of x minus 20, and just tell me sum of this, and we can find that value. Okay, so just calculate and let me know the answer. You can put in the chat box, no problem. So MD from median sum will be this one. So if you substitute, you will be get answer will be 1.2.3, and if you just compare the answer for MD from mean, which is 1.239, so you can compare like from the MD from mean will be larger than the MD from the median, but I can say that median is still lesser. तो इसका आंसर क्या मिल रहा है? बोलो टोटल क्या मिल रहा है? Coefficient of MD from median. What is the answer?
0.0615.
0.06. Somebody put in 15. Okay. So still you can say it is approximate, but I can say still it is minimum. Still it is minimum. So you can this is example number 6. Okay, so we'll put some note on that. So what you can visualize using these problems, that is going to be, we're going to add here. Okay, so you can understand that the arbitrary constant which we are assuming, that can be anything. It can be mean, median, mode, whatever. But what we observe that the MD from median is always better in the case of when you consider A become mean, median, mode, whatever. Okay, so that is our node part. So you can just take down that node. Though A means any constant, is an arbitrarily selected constant, generally for statistical analysis, it is taken as one of the measures of central tendency, such as mean, median, and mode. It is observed that that MD from A is minimum when A is equal to median. So sometime in objective question, it is going to be asked you, like in multiple choice question, this is the problem going to be asked you. Okay, so like when you consider the data for mean and median, so MD from median, which one is going to be minimum? So options are given: mean, median, mode, etc. So you need to select the answers based on that. Okay, that is the one thing you can always remember. And basically, this MD will be useful for the small sample, not a very large sample. So it is very useful in statistical analysis of economic and social phenomena using small sample. This is one of the advantage I can say. So MD is useful in statistical analysis of economic and social phenomena using small samples. Okay. So these are some notes. A note you can always remember. Okay. So you can just look at now what is remaining here. So MD is done, correct? Coefficient of MD is done. Let's go to the next part. Standard deviation. Standard deviation. And this standard deviation is, I can say, out of this all, it is very, very important. Very, very important part in the next measurement. Standard deviation. Standard deviation. Now you can understand the difference between standard deviation and MD and SD. What could be the difference between MD and SD? See, in MD, we are actually, if you look at, we are using the MAD, that's mean absolute deviation, absolute value. Okay, that means even my data is negative, I'm getting the answer is positive. Even my data is negative in some of cases, I may get answer is positive because of the mod. Okay, so because of that, I can say condition, I may fail to get appropriate answer for that, so that I may not use math in some cases. Okay, and that's why the Carl Pearson is a scientist. Carl Pearson is a scientist. Okay, I think he is a statistician. He he has introduced this concepts which is called standard deviation, concept of standard deviation in 1893. Okay, and the very importantly, I can say it is the most important measurement of dispersion and widely used in the many statistical techniques. Okay, and if I talk about in terms of conceptual knowledge of the standard deviation, why it is very important, why it is most useful, because first of all it consider all the data in the picture, like if you see the range, if you see the quartile range, if you see the mean deviation from median, you take somewhere some observation, you left some observations, you may considering only few data, you may sometime taking mod, etc., etc. So there is some problem with happen with the data. But whereas if I talk about standard deviation, in standard deviation we consider all the data. So what is standard deviation? Standard deviation is defined as, see the definition first, as the positive square root of the arithmetic mean understand, arithmetic mean of the squares of the deviation of the observation from their arithmetic mean. It's difficult to like write in terms of statement, but if I write in terms of notation, I will be say that is standard deviation is equal to positive root of variance. So what standard deviation says? What standard deviation says? It is positive square. It is the positive square root, positive square root of arithmetic mean of a square. That means, I notationally if I write, this is going to be x minus x bar with summation square upon it with positive. Okay. So when I take the difference from the mean and square it and take their sum divided by n, I may get the variance. And if I take a positive square root, I will get the standard deviation. Okay. So the interpretation for the SD and interpretation for the variance is same. There is no difference. Only thing is that in the case of variance, you will get the larger variance, and the SD, if you take a square, it becomes small. That is small concept. Okay, this small concept that you can always take care. Okay. So what is the variance? So variance, we have to just remove this positive square. अगर स्क्वायर रूट में निकाल पॉजिटिव स्क्वायर रूट निकाल दूंगा तो ये जो ये पार्ट होगा मेरा am of the square of the deviation from the observation from their mean will be my variance. Are you getting the what is the definition of variance? Standard deviation का क्या formula है? Definition क्या है? It's the positive square root. It's a positive square root of variance. But what is the formula for variance? What is the definition of a variance? Variance is arithmetic mean of a square root, arithmetic mean of squares of a deviation of the observation from their mean. So this is a definition. Okay. So again here in this case, I will putting this all in three terms. First case 1, SD for raw data. Remember, as we done for I can say hopefully mean, median, mode, all, we have to write for this one also, SD for raw data. So raw data के लिए क्या लिखना, what could be the formula for the raw data? So if variate x assumes x1, x2, so on xn, then you may or I can say and am is am of the observation as x bar, observation as x bar, then variance. So first we define variance. So variance is equal to 1 upon n summation x minus x bar ka whole square. And if I get that one, and the standard deviation क्या होगा आपका? It's a square root of variance. ये फॉर्मूला आपको याद रखना है. Standard deviation is equal to what? Standard deviation is equal to square root of variance. But variance कैसे निकालते हो वो फिर आपको आना चाहिए. Okay? So that formula will be just take a square root of this function. You will get the answer for the same. So it's a positive root of 1 upon n summation x minus x bar square. So you can understand here. We are considering all observations. That is a very, very important. Okay, and this is quite useful. And I may say there's a further note part is there, but you can understand note part also very important. That is all important for you. Okay. So what is the important part here? If you look at the variance, part, it is 1 upon n summation x minus x bar square, right? So this is going to be 1 upon n. Just expand using a minus b ka whole square. Expand using a minus b ka whole square. तो क्या होगा? X square minus 2 times summation x into x bar plus n times x bar square. And this is going to be what? This is going to be 1 summation x square upon n minus, and I can write this x bar. What is your x bar here? X bar is equal to what? It is summation x upon n, correct? So what could be summation of x here? N into x bar. So it is 2 times n into x bar. So this n into x bar become x bar square. Okay. So I can, let me write it down for the next step. I can, it's going to be summation x square upon n minus 2 times n x bar square plus n x bar square. So you can just understand. Actually, somewhere I did mistake here. This is divided by n. This is divided by n. Everywhere to divide by n, right? Because I have just opened the brackets. So this n goes away. This n goes away. So what is remaining here? 2. Sorry. This is 2. Just cancel this all. So this is get cancelled. Oh. If you just further simplify, so you can understand. One can use variance ka formula, this one, or one can use variance ka formula, this one. Similarly, when we have a frequency for the raw data, I hope you can write the procedure as we have written for the median and mode. Okay. So you may consider same for that. So second case, I will just considering, I will not going to write entire thing, but you can understand. SD for the group data and raw data, the procedure is same for the writing. SD for group or ungrouped frequency distribution. The formula and procedure, the theory part you can write yourself with no problem. And the variance is going to be, I'm just writing in the formula, f time x minus x bar square upon n. Okay. Here you know x bar is this one, right? Here, this where your n is summation of f, and this x bar is equal to summation fx upon summation of f, or I can say n. Okay. So whether it is group data or whether it is I can say ungrouped data, you know how to write it down, that the procedure that is already I have written, I think, so many times for mean median mode. Okay, so please follow the procedure for writing. So I will just put on the follow the procedure of follow the I'll put it not here, I'll put it in the note, that will be better. So note, follow the procedure of mean or median for grouped and ungrouped frequency distribution. I hope you can understand. So you may take down that writing procedure when you are writing on the textbook or notebook, and then you can follow the procedures. And then similarly, I can say this is the one formula, or we have another one, that is this like this. So it's going to be summation fx square upon n minus x bar square. Okay, so you can follow either this or this based on the. So this is given by the Carl Pearson, who has introduced this standard deviation concepts, and then further more collaboration of other scientists like R.A. Fisher has introduced concepts of coefficient of variation. Okay, so I can say the corresponding relative measures introduced by Professor R.A. Fisher is called as coefficient of variation, which we called CV, and it is defined as, and it is defined as CV is equal to SD upon X bar into 100. And usually it is represented in terms of percentage. Coefficient of variation is usually expressed in percentage. Okay, so this is the, I think with this we have finished, I can say, all absolute and relative measures. So we have a little bit merits and demerits and a problem based on that. Okay, so then you, I think with that 50% will be get over. So the 50%, so like we got 3 lectures, that's why I think 50% got over. So if you have any question, you can ask. No problem. There are some properties of standard deviation. As we have seen for the mean, I can say mean. Like when you add some number with all observation, what is going to be effect in your mean? Or when you subtract, multiply, in certain calculations, certain mathematical calculation, what should happen in your mean? Similarly, when you subtract mean from the subtract any observation from the mean, what could be uh, effect in your standard deviation? Like that. That is all we're going to see in the next class. But if you have any question related to this, the things we have studied today, you can ask. Otherwise, we will get, I think, many lectures because I think Jay sir next week is not going to take lectures because he's going out. So I will take their lectures. So we can discuss. अच्छा जय सर ने कुछ पोस्टर कंपटीशन के बारे में बताया है क्या आप लोग को?
No, sir.
हाँ. So you can just consider the COVID data of like let's say last 7 or 8 months का data ले लो आप. Like how many patients are there, how many active patients are there, how many are death in that particular month, okay? And then try to express in the form of a graph, like pie chart, like simple bar diagram. Or you can, this is the one way. Other way you can compare two cities, like you can compare like Delhi with the Mumbai. What will situation in that particular month? So you can use multiple bar diagram for comparing. Means I just try to understand. See, it is not like कि जो example में दे रहा वही सब लो, ऐसा नहीं है. But this is the one way of understanding the data. How you can understand the data. This is the one way. Then maybe you have studied like when you collect the data, then how do you fit the model? Like fitting the model means how you can fit any distribution. You can find the probability of that. How much percent of the student patient dies in the month of June or month of like that. Okay, so or maybe you can find like you can collect the data of like how many patient like generally the patient having so many disease, then patient will get dies early in stage. Okay, like cancer patients due to heart attack. So those kind of data is not very easy to get it, but when you just search in the Google, maybe you will come across such a data and you can able to like at least you can make. So I think we have a group of 100 students in FIBSC. So we should. I'm expecting at least 25 students will make the PPT, make the poster. Because last time we have around 76 students, and out of that, I think 20 students have prepare posters, maybe based on the data collection and presentation. Okay. So you can do that. You can just work out. You can use concepts of tabulation. Like you can collect the data and present. Present means you can put in the form of table also. It is not like always you can only you can draw the graph. You can do that. You can find out some. You can find out some like you can use the concepts of central tendency. You can calculate mean, median, what it represents. Okay, you can do a lot of things. Okay. Then probabilities may also you can do. Sir has already given some of the name of the probabilities. You can take the data, you try to uh, fit that data, whether that data will be suitable for binomial distribution, suitable for other distributions. Okay, so you can just work on that. And then we'll see if you have any query further. More thing will be instructed by the JSR. So you can, if you have any query, you can ask, no problem. But
So what's the topic name for that?
Topics means sir has not mentioned any topic so far.
No, sir, not yet.
Okay. So hopefully next class I will I will share the topic in the chat box so that you can work on that. And if you have any query, you can discuss. So one topic was, I have remembered, it's a collection of a data and representation of a data. Means you can collect the data and then you can present it in a form of like table, graphs, etc. One topic was this, and another topic was fitting of the distribution, something like that. So I will tell you maybe the next class. Okay.
Okay, sir. Please provide the details, sir.
Yeah. And then we can discuss more thing in the next coming session. And, so we are now left with the, I think, maybe in the 2 or 3 lectures, I will finish this standard deviation, hopefully this week. And then we'll move to the, means it is unit 3 only, but it is a part of unit 3, which is moments, skewness, and kurtosis. Then let's see if we have any query, we can. But you start studying now because now it's very less time. Okay. Regarding today's notes, I think let me finish. You want? I think I have already uploaded the video, so you can watch that video. Okay. But definitely, once this standard deviation will be get over, I will be shared this in GC. I think unit 2 ka notes I have already shared, so you can go through that. Okay. Hopefully, I think last one is not last notes of unit 2 will be not uploaded because I was writing on that. So, but I will upload it. Last, this is I think not uploaded. Maybe I don't know, but videos of all notes are uploaded. So like you can watch video. Definitely, I will going to upload this one. That will be better. You can write it down. Okay. So you have now which class is there? Next.
FC, sir. Steven, sir.
Sorry, FC.
Yes, sir. FC, Steven, sir.
So it will be here only, right?
Yes, sir.
Just wait. Let's join and then I will. And I hope you have done everybody done their practical number. I think which was that 6, na?
6.
Yeah, 6.
Yes, sir.
Yes, sir.
Submitted also, sir.
Yeah, good. So I think I have not prepared all data, but let me share if I have done it some. But as far I just prepared it.
सब आपस में चूतिया फैला के रखे हैं, बस कुछ करने का है नहीं.
So practical number 5, I have this much data. So I think you can able to see the name of who has submitted on time. So these are the very highlighting, like, I don't know, practical number 2, I think it is 3, sorry, this is 3. So So many students have like this mark. Maybe I will get for maybe for unit 4 also. But I think practical number 4 on time. 5 I don't know. Because I think we have total 59 students so far. Like practical 1 they have submitted. So obvious for 2, 3, 4 all we should get same number. Maybe not 59, maybe around 70, 80 students we have. But I don't know what they are doing. But
मैंने लेट सबमिट किया था फर्स्ट प्रैक्टिकल।
हाँ बेटा, तो लेट में है तो आपका नाम है इसमें, देख लीजिए आप, आपका नाम है इसमें।
सर जो हाईलाइटेड है वही क्या?
जो हाईलाइटेड है वो स्टूडेंट्स ने लेट सबमिट किया हुआ है, तो जस्ट चेक योर नेम वेदर इट इज देयर और नॉट।
नहीं है
सर
सर।
एक बार मेरा सर्वर से रिजेक्ट हो गया था, इस वजह से मेरे को उस दिन टाइम अप हो गया था।
हाँ, तो जब कभी भी आप सबमिट करोगे ना तो उसमें आपको अपडेट मिल जाएगा, बिकॉज इट इज इन माय सिस्टम, डेट एंड टाइम आ जाता है उसमें, प्रॉब्लम नहीं आता है उसमें।
यस सर।
तो प्रैक्टिकल 4 का अल्फाबेटिकली अरेंज कर सकते हो क्या प्रॉपर दिखने के लिए?
ओके,
प्रैक्टिकल 4 एंड 5 दोनों।
यस सर, 4 एंड 5 बोथ।
3 तक आपने दिखा दिया था लास्ट लेक्चर्स में, 4 एंड 5 का कुछ बताया नहीं था।
कैन यू सी?
यस सर, थैंक यू।
सर प्लीज स्क्रॉल डाउन।
So you can just check your name, and even if you submitted, then you already got that that you can
मेल।
So there is no problem with
ईमेल
that.
सर।
Yeah.
Yes, sir.
सर प्रैक्टिकल 5 में मेरा नाम नहीं है सर।
तो बेटा आपके मेल पे देखिए, मेल आया है क्या आपको? चेक करो एक बार जाके।
यस सर, एक मिनट चेक कर रहा हूँ।
चेक कर लो, नहीं आया रहेगा तो
तो मेरा नाम भी नहीं आया है।
हाँ, नाम नहीं आया है बेटा आपका भी।
सर मेरा भी नहीं आया।
खान पहिया।
हाँ, this is I think this is till what date I have taken I don't know, maybe last week तक मैंने नहीं लिया था। तो जब अगर आपने last week submit किया रहेगा, can you tell me the date of the like for practical 2? Anyone? Can you tell me the date of that submission date?
सर अभी भी प्रैक्टिकल सबमिट कर सकते हैं क्या?
No, you just tell me first if you are knowing the practical submission date for practical 2.
Last date, sir.
Huh?
The start was 26 November.
Last date, sir.
No. Practical number 5th.
Yes, sir. Start date
22
was
was the last
26
date, sir.
22 last date था. Okay, October 22 ना?
Yes, sir.
Means started I think 16 क्या? I will check and back to you. Maybe some data will be not considered here, but I will check the
Sir, do
data.
you update this?
सर
Do you update
वाले
this
मेरा
data
भी नहीं है।
manually?
Yeah.
नहीं सर, मेरा नाम है सर 5th में।
See, everybody who has submitted their practical, their name will be there. Okay, don't worry about that. But if you are not submitted, please submit it now, even if it is late. Doesn't matter. At least you have submitted. You have
सर
to
मैंने
be right.
5th वाला किया है सबमिटेड, मेरा नाम नहीं आ रहा है।
आएगा बेटा, आएगा। ये मैंने डेटा टिल डेट तक लिया है, ऐसा नहीं अभी तुम आज
हाँ
सबमिट
है।
करोगे।
आ गया मेरा, आ गया
ठीक है, गुड।
सर, मेरा भी आ गया इसमें।
See, don't worry about the your name is there or not. ये मैंने डेटा लास्ट वीक तक का लिया हुआ है। मे बी यू हैव अपलोडेड मे बी yesterday, तो वो डेटा मैंने कल तक का नहीं लिया है। दिस इज नॉट करंट डेटा। ओके, सो होपफुली वंस यू विल बी कंप्लीट, वंस वी कंप्लीट द लास्ट दिस सेंट्रल टेंडेंसी का अभी देखो पेंडिंग है पूरा अभी। So when I just taking all the names of central tendency, I will check the accordingly practical 5 or 4 whatever pending practical is there. Okay, so next time
प्रैक्टिकल उनका दिखाइए ना।
किसका?
प्रैक्टिकल 1।
practical 1.
सर आप मैन्युअली डेटा एंटर करते हो मतलब?
No, it is from the site which
यस
responds
सर,
to
पांचों
साइट पे गूगल शीट से ऑटोमेटिक हो जाता है वैसे?
या हो जाता है।
सर
प्रैक्टिकल में मेरा नाम नहीं है
check your mail beta.
सर।
सर मेल्स नहीं मिल रहे सर मेरे को। मैं सब सबमिट किया, सब में नाम भी दिखा रहा है लेकिन मेल नहीं आ रहा है मेरे को।
कोई बात नहीं, just check like, हम देख लेंगे, कुछ प्रॉब्लम नहीं है। If you have submitted on time, then definitely your name will be there. But don't worry, we can see at the end of the session. Don't worry. I think sir has joined, so I'll make him host.
Okay, sir. Thank you.
सर कैन यू शेयर दैट लिस्ट टू अस? हम लोग अपना चेक कर लेंगे बाद में भी, टाइम सर मतलब लेक्चर के बीच में नहीं हो सकता था।
Let me finish this first with cross checking everything, and then I will share it. Huh?
ओके सर, थैंक यू सर।
Thank you, sir.
Yeah. So we'll meet students next class. Have a good luck.